so it's probably too early in the morning to be doing math right now. But before I get started, I have a few exercises that I would appreciate you humoring me and participating in. And once you know the answer, don't bother raising your hand, just go ahead and shout it out. I swear they're painless. Five plus 3, anyone? Very good. And how about 3 plus 5? First one good. Can anyone tell me how many circles are up there? 4 is the correct response. What time does it say on the clock? 2 o'clock. Very good. And is 45 greater than, less than, or equal to 32? All right, awesome. You all passed. Now, I swear there was a point to making all of you go through those seemingly pointless exercises. And the intended goal was to maybe make you a little annoyed, roll your eyes, and ask yourself, why is she making us do this? This is just silly. So often we forget or take for granted how essential and seemingly automatic our use of elementary math skills is within our daily lives. Until you meet a child or someone with mathematics disorder who does not have the luxury of seeing and processing the types of exercises we just did so easily or naturally. Like Ryan mentioned, my name is Megan Schmidt, and the way I came about researching mathematics disorder was through a research assignment in Dr. Overby's class for childhood psychopathology this semester, where we had to choose a disorder and fashion a comprehensive informational packet geared towards parents. Out of the list of childhood disorders we were given to choose from, mathematics disorder automatically stood out to me, and like any psychology major, as soon as I started reading the diagnostic criteria, I began thinking, oh my God, I so should have been diagnosed with this disorder. Now, while I wouldn't call myself a mathematician, my continued research on the topic soon extinguished the idea that I might be a candidate for the disorder, but nonetheless, my interest on the matter still remains. One of the primary issues with mathematics disorder, or MD for short, is how to define it. This is because MD covers a broad range of possible learning deficits, including one's reading level, memory capacity, visual coordination, and ability to use abstract concepts, all of which are additionally difficult for professionals to observe and measure. Some of the more common warning signs for MD that parents and teachers should take note of include having a good memory for recalling printed words, but a poor memory for remembering Arabic number symbols, an inability to follow step-by-step instructions that involve directional cue terms, such as left, right, north, and south, an inability to grasp the concept of games that involve math-based strategies like card and board games and keeping track of the scoring system, failing to make the connection between applied concepts and mathematical rules and procedures, like the example we carried out at the beginning of this presentation, and recognizing that 3 plus 5 and 5 plus 3 will result in the same answer of 8 regardless of the order the numbers come in, and consistently having trouble distinguishing which math operation, either add, subtract, multiply, or divide, to use when given a word problem. Above all, it is important to acknowledge that difficulties in understanding math do not automatically mean that a child has MD. A variety of extenuating circumstances could be the more likely direct link for why a child is unable to acquire necessary math skills. Such extenuating circumstances need to be accounted for when investigating whether or not the child is a candidate for MD, including inadequate teachers, cultural differences, diagnosed mental retardation, or physical illness that may, in turn, affect a child's focus and motivation. School-age children will all learn at their own pace, and math, more so than any other academic subject, takes time, practice, and patience in order for it to make practical sense and stick to one's long-term memory. Some of the more common standardized tests used by professionals to help decipher whether or not a child has MD are the arithmetic subtest for the WRAT3 and the mathematical reasoning subtest for the WIAT. Children diagnosed with MD tend to score well below the average range on these tests. The total score on these tests allows professionals to compare a child's actual overall level of mathematical skill and understanding to the child's expected age-appropriate level of mathematical skill and understanding. A child's error patterns, such as choosing the wrong operation for a word problem, doing an order of operations problem out of order, or not aligning the numbers and place values in an equation properly, enable professionals the ability to assign a certain form of intervention or treatment that best meets the needed growth areas for the child's form of MD. In addition to significantly low math scores on a standardized test, the DSM requires 2 additional criteria that a child must meet in order to be officially diagnosed with MD. The second criteria alludes to the child having a consistent deficiency in mathematical ability to the point that it starts to affect and disrupt daily encounters with math-based scenarios faced both in and outside of the classroom setting, such as reading a calendar or following a recipe. Oftentimes, children with MD will try to avoid these types of scenarios altogether. Finally, a child must have a notably low level of mathematical functioning and comprehension, regardless of an existing deficit of one of the 5 senses. There is not likely one root cause for MD, rather it is likely triggered by any combination of issues, including genetic inheritance, poor teaching and classroom environment, being tested on material not yet covered in the classroom, and no self-confidence in math. However, given its distinction as a learning disability, MD is first and foremost based upon something lagging within the brain. Neuroimaging efforts have identified the parietal lobes as the area of the brain where mathematical processing takes place. Narrowed down even further, the ability to distinguish between large and small numbers, for example, that 32 is greater than 20, and carry out the steps necessary in configuring a math equation, all take place within an area in the parietal lobes known as the intraparietal sulcus, or IPS for short. One study indicated that when tested on problems involving number comparisons and concept of number size and representation, the IPS in children with MD was substantially less active than the IPS in children with normal math ability. Thus, these results suggest children with MD lack the full capability to mentally picture number size, as well as compare and contrast number sizes. An inability to connect number sizes to their corresponding Arabic number symbol, as we did in one of our problems at the beginning of this presentation, was also due to a low-functioning IPS. It is believed that children with MD attempt to make up for this brain loss by activating alternative areas of the brain. Unfortunately, these areas of the brain are not geared toward math problem-solving processes, and as a result, generate very little success for children with MD. The way we learn math is fundamentally different from the way we learn to read. Our understanding of math grows, changes, and adapts as our perspectives evolve from being more concrete to being more abstract. Because of this disorganized evolution of math, understanding and development, pinpointing the common age for the onset of MD becomes rather difficult and unclear. However, given the widespread presence of MD across a variety of age groups, it unfortunately appears to be a disorder with staying power. Because MD poses different challenges and symptoms for different people, it is safe to assume that each person's course of development will be influenced by MD in its own unique way. For example, children with more prominent language deficits will have different difficulties in math than a child with brain-eye coordination issues, or a child with poor short and long-term memory for remembering important math facts. Because classroom teachers cannot structure lesson plans around each and every child's math flaws, priority goes to planning lessons around the child's current developmental stage according to the practical math skills that child will need to know before he or she enters the new stage of development. Math deficits are commonly associated and dependent upon the child's developmental stage. Some characteristic mathematical difficulties recognized during early childhood involve counting, matching Arabic numbers to a corresponding number of pictured items, sorting items by shape, size, or color, recognizing patterns, telling the difference between smaller and bigger or wider and taller items, and comprehending that numbers are representative of an exact amount or quantity. School-age children often have trouble when it comes to using addition, subtraction, multiplication, and division, retaining basic math facts like the times table, applying basic knowledge of processes and procedures to generalized word problems, transferring understood mental concepts onto paper in an organized manner, and comprehending mathematical concepts in written form on a board or in a textbook. Adolescents and adults typically have issues that involve moving on to more advanced math applications that involve complex equations and statistics, as well as grasping and retaining math vocabulary and terminology. Given the great amount of mystery that still shrouds mathematics disorder, current treatment methods lie solely in the hands of teachers. Some alternative teaching methods that have been found to help improve math achievement levels in children with ND include breaking down larger assignments into several smaller assignments for students with ND and giving them ample amount of time so as not to overwhelm them, making abstract concepts into concrete concepts through utilization of geoboards, base 10 blocks, Cuisenaire rods, geometric blocks, counters, and play money during word problems and role-playing scenarios, measuring actual common household and classroom objects with rulers and temperature with thermometers as a way of giving children with ND a point of reference and hands-on experience, encouraging use of graph paper to help those students with the type of ND that originates from poor brain-eye coordination to help organize and structure their thoughts, as well as help them properly align written out equations and place values. Encouraging the practice of estimation as a means to help predict the solution as the first step to take before mechanically problem solving. While mathematics disorder can be a long-term challenge for the child, the parents, and teachers, early and continuous intervention remain the fundamental keys to success. Above all, revealing to a child their math strengths and weaknesses helps the child to better acknowledge their areas for needed growth, but also to appreciate their strong points and ways to continuously use these strengths to their advantage. Are there any questions?
Yeah. Did you, in your project, did you say what should parents do if they start to worry? You know, if they start to think some of this, what should be their first step?
It didn't really go into full depth on that, but it definitely had separate warning signs for that parents might pick up on versus what teachers might pick up on, and that they should definitely collaborate together so that they have more of a well-rounded perspective of the child's behaviors and capabilities in different environments. Yes, in the back.
Was there any percentages on how many children actually suffer from MD?
Since it was kind of a broad and all-encompassing definition, and there's still so much mystery attached to it, the prevalence rate in the total population of school-age children was anywhere from 3 to 13%. So, are there any other questions? Yes?
Did you find any other disorders that children tend to have at the same time that they would have mathematics disorder?
Yeah, it was interesting. There was a lot of information actually on children with ADHD were commonly diagnosed with mathematics disorder as well. And I think that percentage jumped from that 3 to 13% to about 25% for children that were believed to have both ADHD and mathematics disorder. But there was also a line of questioning as to whether math deficits were actually caused by something as mathematics disorder, or whether that was from the side effects of ADHD, lack of attention and focus. Are there any other questions? Thank you.